Welcome back, generals, to another Let's Fix Generals 0 hour to make the best game ever. Okay, so last video we made, we looked at data here. The data that object dump, llvm object dump would export from our MachO binary. And yeah, we understood the relationships between functions and the source file. They are contained in the header files, right? Okay, so that's good. So now there is a question. What about template functions in headers? I wonder. So we did see there was something about TCC file. Let me see that. TCC. I wonder if that is just a name from the Mac OS, if they have natively this name, or does a compiler generate this? As in like, okay, it's a list.header, but we call it TCC to say that this is a templated file. And this is a file, it's contained, I don't know. Let's search for this in here, list.tcc. Does this exist? Yeah, it does. It is a file, okay. Okay. So if we have a function, let's try to find one up here. Can we perhaps find I don't know. macdisplay.cp. Okay. It's not not the typical name for a CPP file. They tried, right? Yeah. So it would be interesting to find the templated function and take a look at that, because I would be interested to see where it then goes, right? Yeah, I don't know. CPP. Okay, well, we eventually will stumble over one. Okay, I wanted to look at this vtable thingy. So for example, actually, let's look here. So hidden vtable. So let's take this guy, this address, and let's look at this in here in EDR jump address. Okay. Well, that is not a vtable. Oof. What does that mean? Maybe that was part of the other executable. Yeah. Okay, let's look at this one. Vtable for this. Yeah. Let's take a look. Aha, there we go. So the vtable contains a type info. Type info for that. And then the next is query interface. So aha. Can we invert this somehow here? Okay, so this refers to, let me make a search here. Let's take this guy and we need to invert it 0, 0, 0, 2, 0, 6, right? And then we take not match case, find. There we go. Yeah, it's here. Okay, and then so the vtable. So the vtable will have these pointers. What about this one here? So this one is zero 7F 99. There we go. Oh shit. Okay, there we go. Type info. Type info. Okay, I don't understand. What does that mean here? How is this helpful? Well, how? I don't understand. Ah, it's this here. Okay. But it's not demangled. What does that mean then? CXX ABI version 120. Okay, so we probably would need to find out how we. Let's ask ChatGPT. This type info. How do we demangle this MachO type info name? So, is a mangled C++ symbol. To demangle it, follow the C++ name mangling convention. The symbol uses Itanium C++ ABI, which is standard for most non-Microsoft. Okay. Namespace. Okay. Class name. vtable. The full demangled name is vtable4. What? C++ ABI is a namespace for the C++ ABI implementation. Okay. Then I wonder, why is this not demangled here already? Strange. I don't quite understand that. Okay, but we have the vtable and we understand the vtable, yeah. Okay. So these are all the virtual functions, essentially, of the type then, vtable. This type has this vtable, so these are all the virtual functions. And how do we know that they override something? Well, probably if a inherited class has the same function here, this part here, right? No. Okay. What do we have here? Okay. Good. Let's keep looking a little bit here. We just look around this session. We don't program anything. Just easy peasy. Type info name. Okay, let's take a look what that is. Type info name. Let's see. Type info name. What does this tell us? So I guess a 10 means that this is 10 characters long, right? It's not 0 terminated. 10. Well, it is 0 terminated here. It's 10 characters, I assume. One direct has 7. Direct has 6, 7, 8, 9, 10. Yeah, 10 characters. Okay, but what does this tell us? This. What does this tell us? I don't know. Let's ask ChatGPT. What is the use of type info of a type info name or any other class? Mechanism provided runtime, which allows you to query and manage type information about objects during runtime. Here's what it's used and why it matters. Type info name is a representation of a class types that is stored in the binary, often used internally by RTTI. In the context of Ethereum, this name is associated with the type info structure. For a class like this, its type info might be referenced in code as part of RTTI operations, such as dynamic casting. Okay. Type ID. The type name of the object. Useful in debugging or in implementing systems requiring dynamic type introspection. Dynamic cast. Okay, it allows this dynamic cast, yeah. Safe down cast. Exception handling. Okay, but I don't think it's useful for our purposes because the class name, it's part of the function, part of the function name. So why do we care? I don't know. Okay. Okay, let's see what else we have here. Data. Last frame, play sizzle. Game client updates. Last frame. Data. Okay, this looks to me like there's a static. One is data, the other is BSS, so there's some difference in the initialized state or something, if I recall correctly. See game client update. If we search for this in Thyme, is it already? Yeah, it's already implemented. Look at that. Let's see. There's a static pool. Yeah, play scissor. It's initialized to false, and then there's a last frame. Last frame here. Last frame, but it's also initialized. Let's see, what was the difference between data and BSS? Oh shit, I didn't want to do that. Data, initialize global variables. Data, static int a. BSS, uninitialized static variables. Okay, so that's interesting. So here BSS, this place, wait, I already forgot. BSS is uninitialized play sizzle. So play sizzle is supposed to be uninitialized, but here it is initialized. So this is actually wrong. This initialization is wrong. Huh. Strictly speaking. Yeah. So when we look at this, here, so last frame, it should be -1, if I remember correctly. Yeah, FFFF is -1. Okay. And here, the other one, what was it? Play sizzle, uninitialized. Uninitialized. Ah, yeah, okay. Question mark. Look at that. Interesting. Okay, cool. Okay. We are equipped with knowledge now. Look at that. Yeah. We are equipped with knowledge. Good. Let's make this a bit larger so you can also see it maybe. Good. Let's see what else we have here. So this is data. And so where does this update function come? Here. Okay. What is this here? What is that? I don't know. I don't know what is this supposed to do here? What does it tell us? I don't know. 3 times mentioned here. 1, 2. I don't know. I don't know what this is supposed to give us. Okay, but maybe we just skip it and that's it. Strange. So is this the first mention of this address? Let's see. Yeah, okay. Okay. Data. This address, if we look for this address, we find this update. So to me, it looks like we don't actually need to demangle this name with the F here at the end. Instead, the address is shared by some other by some other symbol, which already comes before that here in the text dot hidden, and that has a demangled name here. With the F. Yeah. Text. Yeah. Hold on. This. 6, 7. It comes actually behind it, not before. Behind. So maybe it would make sense to make 2 read passes. First, make a pass and find all these guys here. I don't know. Dot hidden. Text section. Ah. Hmm. Okay, what is a non-virtual thunk? That's another interesting question. Let's check here. Oof. It is a function. Non-virtual thunk. Non-virtual thunk. Non-virtual thunk. Okay, let's search for this guy. Game client. So it's probably already in here now. Let's see. Game client, yeah. Game client. Load. Post process. There we go. Yeah. But it is a virtual. Why does it say non-virtual then? Okay, let's ask ChatGPT. What does non-virtual thunk mean? A small piece of compiler-generated code used to adjust the this pointer when calling a member function. This adjustment is necessary to account for the offset between the base class and the derived class. When the function being called is inherited but non-virtual. When the derived wait, what? To account for the offset between the base class and the derived class when the function being called is inherited but non-virtual. Huh? Overrides base func. Huh? So, but this must be a virtual function, no? Why does it say non-virtual thunk? If base is not located at the start of derived, this pointer would need adjustment before calling derived func. When disassembling, you might see symbols like this indicates a compiler generated function that adjusted this pointer and forwards the call to derived func. For non-virtual function calls. In non-virtual function calls in class hierarchies, especially with multiple inheritance. Huh? For non-virtual function calls. I'm not sure, does this mean that a function that has a non-virtual thunk generated is not a virtual function? Maybe it is. Not necessarily. The presence of a non-virtual thunk does not imply that the function is not virtual. Okay, makes sense. Can be generated even for virtual functions. Okay, I understand. It's probably if you call the virtual function inside the class, that you don't need to go to the vtable to call this, but you can have this non-virtual thunk. I see. Does not perform a vtable lookup. Okay, I understand. Okay, that's fair. So I don't think we care about this then. Yeah. Okay, good. Okay. Okay, so if we look for this here, for example, then we should find another one here. Yeah. F text. Okay. That's good. Okay, let's look a bit around here. Yeah. Okay. Type info. So this type info, let's see. Let's take this guy. Let's see what other there are. VMI. So I still don't know what to do with this class type info. Let's see. What knowledge does the type info give us for type? Essential information. Runtime type information. Type identification. Identify the object of the type of an object or class at runtime. Type ID. But type info. But what is the use of this? I don't understand. So let's look at this here. Type info. Type info. vtable. What? What? Okay, what's going on here? So I see there's some hierarchy here. Oof. But I don't understand this yet. Yeah. Yeah, we need to understand this as well. Yeah. So somehow EDR figures out some hierarchy here. The question is, how does it do that? So there is a type info here. Thyme module interface. Well, I don't know how it comes to these conclusions. I don't know. Type info vtable. I don't understand. We need to study this as well here. Okay, how about we study this in the next session? Yeah. Right now, I don't understand it. It's not intuitive. But there must be some system behind this. It's probably something simple. But I really don't see it. Yeah. Good. Anyway, I think it's enough. Time for sleep. Good. Yeah, let's make it a short session here. Then I wish you a great day or night. Until next time. Goodbye.